This documentary is intended for teens and adults who want to learn more about weather, climate, and natural disasters. Recommended age, 15 plus. Ages 15 and older may watch independently. Ages 11 to 14 are encouraged to watch with an older sibling, parent, guardian, teacher, or another trusted adult. Some topics may be serious or emotional, especially for viewers who have personally experienced hurricanes, floods, wildfires, tornadoes, droughts, blizzards, or other natural disasters. This documentary contains discussions and images related to extreme weather events, natural disasters, climate change, environmental impacts, historical disasters and loss of life. Viewer discretion is advised. Timestamps are included throughout the video if you would like to skip to specific sections. About this documentary. This documentary was created primarily using artificial intelligence tools, including AI-generated visuals, graphics, narration assistance, research assistance, and editing support. While every effort has been made to present accurate information, viewers are encouraged to consult official scientific and government sources for additional information. Thank you for watching. Now, let's begin. To understand the environmental challenges facing our world today, we first need to understand one of the most important scientific topics of the 21st century, global warming. Global warming refers to the long-term increase in Earth's average surface temperature. While Earth's climate has naturally changed throughout history, scientists have observed a rapid warming trend since the late 1800s, especially during the last several decades. At the heart of this process is something known as the greenhouse effect. The greenhouse effect is a natural process that makes life on Earth possible. Sunlight passes through the atmosphere and warms the planet's surface. The Earth then releases some of that energy back toward space as heat. Certain gases in the atmosphere, including carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap part of that heat and prevent all of it from escaping. Without the greenhouse effect, Earth would be far too cold for most life to survive. The challenge today is that human activities have strengthened this natural process. Burning coal, oil, and natural gas for energy, transportation, and industry releases large amounts of carbon dioxide into the atmosphere. Agriculture, land use changes, and industrial processes release additional greenhouse gases. As these gases accumulate, more heat becomes trapped, causing global temperatures to rise. The evidence for warming can be seen around the world. Global average temperatures have risen by more than 1 degree Celsius since the late 19th century. Glaciers and ice sheets are shrinking. Sea levels are rising. Oceans are absorbing enormous amounts of heat. Heat waves are becoming more common in many regions, and ecosystems are changing as plants and animals respond to shifting climate conditions. Global warming affects more than temperatures alone. It influences water supplies, agriculture, public health, infrastructure, wildlife, and economies. The future is not predetermined. The choices made by governments, businesses, communities, and individuals will influence how much warming occurs during the coming decades. Every fraction of a degree matters. And understanding global warming is the first step toward understanding everything that follows in this documentary. But rising temperatures are only part of the story. Around the world, one of the clearest signs of a warming climate is the growing frequency and intensity of extreme heat events. Next, we'll examine how heat waves are becoming more dangerous across North America, Europe, and Asia. One of the clearest signs of a warming world is the increase in extreme heat. Heat waves are becoming more frequent, lasting longer, and reaching higher temperatures across much of the planet. While heat waves have always occurred naturally, today's events are developing in a warmer atmosphere, making record-breaking temperatures more likely. Scientists point to several reasons for this trend. Rising global temperatures increase the baseline for extreme heat. Cities often become even hotter because buildings and pavement absorb and trap heat. Drought conditions can also make heat waves more intense by drying soils and vegetation. Recent years have provided dramatic examples. In June 2021, a historic heat dome affected the Pacific Northwest of North America. Temperatures approached 50 degrees Celsius in western Canada, shattering records and causing widespread impacts. In July 2023, Death Valley, California, reached 128 degrees Fahrenheit, among the hottest temperatures reliably recorded on Earth. Across Asia, major heat waves have become increasingly common. India and Pakistan experienced dangerous temperatures above 45 degrees Celsius during the spring of 2022. Southeast Asia faced another severe heat wave in 2023, affecting millions of people. Japan experienced one of its most remarkable heat events during the summer of 2025. The country recorded its hottest summer since national records began in 1898. Temperatures exceeded 40 degrees Celsius in several cities, and Isazaki reached 41.8 degrees Celsius, setting a new national record. Hospitals treated thousands of people for heat-related illnesses while energy demand surged. Europe has also experienced repeated extreme heat. Temperatures exceeded 40 degrees Celsius in several countries during recent summers, contributing to drought, water shortages, and agricultural losses. The message is becoming clear. Extreme heat is no longer a rare event. It is becoming one of the defining climate challenges of the 21st century, affecting public health, ecosystems, agriculture, and economies around the world. But a warmer atmosphere doesn't just increase heat. It also allows the air to hold more moisture, raising the risk of heavier rainfall and more destructive flooding. Water is essential for life. But when too much rain falls in too little time, it can quickly become one of nature's most destructive forces. As global temperatures rise, the atmosphere can hold more moisture. For every degree Celsius of warming, the air can hold about 7% more water vapor. This increases the potential for heavier rainfall and more extreme flooding events. Around the world, communities are experiencing the consequences. In July 2025, Central Texas experienced catastrophic flooding after slow-moving storms produced extraordinary rainfall. Some locations received more than a foot of rain in a short period of time. Rivers rose rapidly, roads were washed away, and communities were devastated. The flooding became one of the deadliest weather disasters in the United States in recent years. Europe experienced a historic flood disaster in July 2021. Torrential rainfall struck Germany, Belgium, the Netherlands, and neighboring countries. Rivers overflowed, entire neighborhoods were submerged, and more than 200 people lost their lives. Some areas received a month's worth of rainfall in just a few days. In China, extreme flooding has also become a growing concern. During 2024, the Bei River in Guangdong province experienced what officials described as a once-in-a-century flood event. Water levels rose to dangerous heights, forcing evacuations and threatening millions of people living downstream. These disasters highlight a common pattern. Warmer temperatures increase evaporation, placing more moisture into the atmosphere. When weather systems develop, that extra moisture can fall as intense rainfall, increasing the risk of flash floods and river flooding. The impacts extend far beyond the floodwaters themselves. Homes, businesses, roads, bridges, and power systems can be damaged or destroyed. Communities may face years of recovery, while economic losses often reach billions of dollars. Scientists have observed an increase in heavy precipitation events across many regions of the world. While not every flood is caused by climate change, a warming atmosphere is making many extreme rainfall events more likely and more intense. The trend is becoming increasingly clear. Flooding remains one of the costliest and deadliest natural hazards on Earth, and many communities are now facing risks that previous generations rarely experienced. Understanding these changes is essential as societies prepare for a future with more extreme weather. Too much water can bring disaster. But in other parts of the world, the opposite problem is becoming increasingly severe. Next, we'll examine droughts and water shortages affecting Australia, Brazil, and the United States. Drought is one of the most costly and widespread climate disasters on Earth. Unlike hurricanes or floods, droughts often develop slowly over months or years. But their impacts can be enormous, affecting water supplies, agriculture, ecosystems, energy production, and entire economies. Scientists have found that rising temperatures are increasing evaporation from soils, lakes, and reservoirs. In many regions, changing rainfall patterns are making dry periods longer and more severe. As a result, droughts are becoming more frequent and intense in many parts of the world. Australia provides one of the most well-known examples. The Millennium Drought affected much of southeastern Australia and placed enormous pressure on water supplies, agriculture, and ecosystems. Reservoir levels dropped dramatically, and extreme heat helped fuel destructive bushfires. Even today, Australia continues to face challenges from recurring drought and heat extremes. In Brazil, severe drought conditions have affected both the Amazon basin and southeastern regions of the country. During 2023 and 2024, major rivers reached exceptionally low levels, disrupting transportation and isolating communities. Drier conditions also increased wildfire activity and placed additional stress on one of the world's most important ecosystems. The United States has also experienced widespread drought during the past decade. Large portions of the West, Southwest, and Great Plains faced prolonged dry conditions. Major reservoirs such as Lake Mead and Lake Powell reached historically low levels, raising concerns about water supplies for millions of people. The impacts of drought extend far beyond a lack of rainfall. Crop yields can decline, food prices can increase, wildfire risks grow, and ecosystems become more vulnerable to damage. Communities, businesses, and governments must often make difficult decisions about water use during prolonged dry periods. While drought has always been a natural part of Earth's climate, a warming world is increasing the likelihood of more severe drought events in many regions. Improving water management, protecting ecosystems, investing in resilient infrastructure, and reducing pollution can help communities better prepare for future drought challenges. The choices made today will help determine how prepared future generations are for a hotter and drier world. Wildfires have always been a natural part of many ecosystems. But in recent years, some of the largest and most destructive fires ever recorded have occurred across multiple continents, affecting millions of people and vast areas of land. Several factors contribute to wildfire activity. Rising temperatures dry out vegetation, prolonged droughts leave forests vulnerable, and longer dry seasons create more opportunities for fires to ignite and spread. Strong winds and extreme weather can then turn small fires into rapidly growing disasters. One of the most devastating wildfire events occurred during Australia's Black Summer of 2019 and 2020. Fires burned across large portions of the country, destroying thousands of homes and impacting wildlife on an unprecedented scale. Smoke from the fires spread thousands of miles across the region. In Canada, the 2023 wildfire season became one of the worst in the nation's history. Massive fires burned across multiple provinces, forcing evacuations and covering large portions of North America in thick smoke. Air quality alerts extended far beyond Canada's borders. Russia has also experienced enormous wildfire outbreaks, particularly across Siberia. Some of these fires have burned in remote regions for weeks or months, releasing large amounts of carbon dioxide into the atmosphere. In the United States, California's Camp Fire in 2018 became one of the deadliest and most destructive wildfires in modern American history. The fire devastated the town of Paradise and demonstrated how quickly extreme fire conditions can threaten entire communities. Europe has not been spared. Greece experienced the deadly Attica wildfires, while Portugal has faced repeated destructive fire seasons driven by extreme heat and drought conditions. The Amazon rainforest has also seen major fire outbreaks. These fires threaten biodiversity, release carbon into the atmosphere, and place additional stress on one of the world's most important ecosystems. Wildfires affect far more than forests. They destroy homes and infrastructure, harm wildlife, damage ecosystems, and create serious health risks from smoke pollution. The economic costs often reach billions of dollars. Scientists expect wildfire risk to increase in many regions as temperatures continue to rise and drought conditions become more severe. Reducing ignition risks, improving forest management, strengthening emergency preparedness, and investing in early detection systems can help communities better adapt to a future where extreme wildfires may become more common. California provides one of the clearest examples of how climate extremes can occur within the same region over a relatively short period of time. Between 2011 and 2017, California experienced one of the most severe droughts in its recorded history. Reservoirs dropped to critically low levels, mountain snowpack shrank dramatically, and millions of trees died from drought stress and heat. Water restrictions became common across the state, farmers faced major challenges, and wildfire conditions worsened year after year. The drought affected nearly every part of California. Major reservoirs reached historic lows, groundwater supplies were heavily used, and ecosystems struggled under years of limited rainfall. By the middle of the decade, concerns about long-term water security had become a major issue across the state. Yet only a few years later, conditions changed dramatically. Powerful Pacific storms brought enormous amounts of moisture into California. During the winter of 2016 and 2017, rainfall totals surged well above normal in many locations. Rivers overflowed, roads were damaged, landslides occurred, and communities faced widespread flooding. Some areas received more than double their average annual rainfall. This rapid shift from extreme drought to extreme flooding is often called climate whiplash. Instead of experiencing stable weather patterns, regions swing between opposite extremes. Long dry periods are followed by intense rainfall events, creating new challenges for communities and infrastructure. Scientists have found that a warmer atmosphere can hold more moisture, increasing the potential for heavier rainfall when storms occur. At the same time, rising temperatures increase evaporation and can worsen drought conditions during dry periods. The result is a future where California may experience both severe droughts and extreme flooding rather than one or the other. These changes affect water supplies, agriculture, wildfire risk, transportation systems, and natural ecosystems. Preparing for this future requires stronger infrastructure, improved water management, better emergency planning, and long-term climate resilience. California's experience demonstrates that climate change is not simply about warmer temperatures. It is also about increasing extremes and the growing challenge of adapting to a more variable climate. Hurricanes have always been a part of life along the Atlantic and Gulf coasts. But the 21st century has produced some of the most destructive and costly storms ever recorded in the United States. As ocean temperatures rise, hurricanes have access to more energy. A warmer atmosphere can also hold more moisture, increasing the potential for extreme rainfall and flooding. Rising sea levels add another layer of risk by allowing storm surge to reach farther inland. Several hurricanes have become defining disasters of the modern era. In 2005, Hurricane Katrina devastated the Gulf Coast and remains one of the deadliest and costliest natural disasters in American history. Entire communities were flooded, and recovery efforts continued for years. In 2017, Hurricane Harvey stalled over Texas and produced record-breaking rainfall, causing catastrophic flooding across the Houston region. The same year, Hurricane Maria devastated Puerto Rico, creating a humanitarian crisis and causing long-lasting damage to infrastructure and power systems. More recently, Hurricane Ian struck Florida in 2022 as a powerful Category 4 storm. Storm surge, destructive winds, and widespread flooding caused billions of dollars in damage. In 2024, Hurricane Helene brought devastating flooding far inland, affecting communities from Florida to the Appalachian Mountains and demonstrating that hurricane impacts can extend hundreds of miles from the coastline. Scientists have observed that the strongest hurricanes are producing heavier rainfall than similar storms did decades ago. Sea level rise is also increasing the impacts of storm surge and coastal flooding. At the same time, population growth in coastal regions means more people and infrastructure are exposed to risk. The costs of hurricanes continue to rise, not only because of stronger storms, but because more homes, businesses, and transportation systems are located in vulnerable areas. Preparing for the future requires a combination of stronger building standards, improved forecasting, resilient infrastructure, emergency planning, and the protection of natural barriers such as wetlands and dunes. Hurricanes are not new. But the evidence suggests that some of the most intense storms are becoming more destructive in a warming world. The challenge facing communities is not simply how to recover from the next storm, but how to prepare for a future where the risks may continue to grow. The lessons of the 21st century are clear: hurricanes remain one of America's greatest natural hazards, and resilience will be critical in the decades ahead. Tropical cyclones are among the most powerful storms on Earth. Depending on where they form, they may be called hurricanes, typhoons, or cyclones, but they are all fueled by the same process: warm ocean water providing energy to the atmosphere. Over the past several decades, scientists have observed that ocean temperatures have continued to rise. Warmer oceans can increase the amount of moisture and energy available to developing storms, helping some of the strongest tropical cyclones become even more intense. The 21st century has seen several devastating storms around the world. Cyclone Nargis struck Myanmar in 2008 and became one of the deadliest natural disasters of modern times. Typhoon Haiyan devastated parts of the Philippines in 2013 with extreme winds and storm surge. In the Atlantic Basin, hurricanes such as Katrina, Maria, Harvey, Ian, and Irma caused widespread destruction and billions of dollars in damage. The impacts of tropical cyclones extend far beyond strong winds. These storms can produce catastrophic flooding, destructive storm surge, infrastructure damage, economic losses, and long-term impacts on communities. Rising sea levels can also increase coastal flooding during major storms. Tropical cyclones form in several regions around the world, including the Atlantic, Pacific, and Indian Oceans. While their names differ, the challenges they create are similar for millions of people living in vulnerable coastal areas. As populations continue to grow along coastlines, improving forecasting, strengthening infrastructure, protecting natural coastal barriers, and preparing communities for disasters will become increasingly important. The lesson from the past 25 years is clear: tropical cyclones remain a global threat, and resilience will play a critical role in reducing future losses. Winter 2025 to 2026 was one of the most unusual winters North America has experienced in years. Across the continent, communities saw completely different extremes at the same time. From record cold and historic snowstorms to floods, warmth, and drought, this winter highlighted the growing contrast in our changing climate. The season began with extraordinary cold across Alaska. Some locations dropped toward -50 degrees Fahrenheit as Arctic air remained locked in place. Heavy snow buried communities and created difficult conditions across much of the state. But later in the winter, the pattern changed dramatically. Warmer air pushed northward, bringing rain to snow-covered areas. Rivers rose rapidly, flooding developed, and communities faced a rare winter flood threat. Seeing severe flooding and extreme cold occur in the same season was remarkable. Meanwhile, the eastern United States experienced its coldest winter since 2014 to 2015. The Ohio Valley, Great Lakes, Mid-Atlantic, and Northeast endured repeated Arctic outbreaks, dangerous wind chills, and multiple winter storms. The season reached its peak during the historic East Coast blizzard of February 22 and 23, 2026. Snowfall exceeded 2 feet in many locations, with some areas receiving more than 3 feet. Hurricane-force wind gusts created blizzard conditions, over 600,000 customers lost power, and states of emergency were declared across parts of the Northeast. While the East battled snow and cold, much of the West experienced one of its mildest winters on record. Temperatures stayed well above average, mountain snowpack remained far below normal, and concerns grew about drought and wildfire risk heading into spring. Then came another surprise. On May 5 and 6, Colorado was hit by a major late-season snowstorm. Heavy snow blanketed parts of the Front Range after a winter that had been relatively dry. The storm was a striking example of how weather can swing rapidly from one extreme to another. So what connects all of these events? A warmer atmosphere can hold more moisture, increasing the potential for heavy snow, rain, and flooding. At the same time, the Arctic continues warming faster than much of the globe, which can influence large-scale weather patterns and contribute to stronger temperature contrasts. Winter 2025 to 2026 was not simply cold or warm. It was a season defined by extremes. From Alaska's deep freeze and floods, to the coldest eastern winter in over a decade, to the mild west and Colorado's May snowstorm, it served as a powerful reminder that climate change is not just about rising temperatures. It's also about increasing weather extremes and a climate that is becoming more unpredictable. Winter 2025 to 2026 was truly a winter to remember. Winter 2025 to 2026 was one of the most unusual winters North America has experienced in years. Across the continent, communities saw completely different extremes at the same time. From record cold and historic snowstorms to floods, warmth, and drought, this winter highlighted the growing contrast in our changing climate. Glaciers are often called the planet's water towers, storing vast amounts of fresh water and slowly releasing it into rivers, lakes, and ecosystems around the world. But today, glaciers are shrinking at an alarming rate. From Alaska and the Canadian Rockies to the Alps, Andes, Himalayas, and New Zealand, glaciers are retreating almost everywhere on Earth. Rising temperatures are causing more ice to melt each year than can be replaced by winter snowfall. Scientists estimate that the world's glaciers have lost roughly 5% of their total ice mass since the year 2000. While that number may sound small, the amount of water involved is enormous and is already contributing to rising sea levels around the globe. Several factors are accelerating glacier loss. Warmer air and ocean temperatures increase melting. More precipitation is falling as rain instead of snow in many mountain regions. Reduced snowpack means less fresh ice can accumulate, while darker rock and soil exposed by melting ice absorb more sunlight and generate even more warming. The consequences extend far beyond the mountains. As glaciers shrink, sea levels continue to rise, increasing the risk of coastal flooding. Millions of people depend on glacier-fed rivers for drinking water, agriculture, and hydropower. In many regions, glacier retreat threatens long-term water security. Melting glaciers can also increase natural hazards. Unstable slopes, landslides, and dangerous glacial lake outburst floods become more likely as ice disappears and mountain landscapes change. Scientists are closely monitoring these changes using satellites, field measurements, weather stations, drones, and computer models. These tools help researchers track glacier health and better understand future risks. The evidence is clear. Glaciers are retreating on nearly every continent. What was once considered a slow geological process is now occurring within a human lifetime. Glaciers are more than frozen landscapes. They provide fresh water, support ecosystems, influence sea level, and serve as one of the clearest indicators of a warming world. As temperatures continue to rise, the future of many glaciers remains uncertain. Protecting them ultimately means addressing the warming that is causing them to disappear. The ice is melting, and the changes are already being felt around the world. Glaciers are often called the planet's water towers, storing vast amounts of fresh water and slowly releasing it into rivers, lakes, and ecosystems around the world. But today, glaciers are shrinking at an alarming rate. From Alaska and the Canadian Rockies to the Alps, Andes, Himalayas, and New Zealand, glaciers are retreating almost everywhere on Earth. Rising temperatures are causing more ice to melt each year than can be replaced by winter snowfall. Scientists estimate that the world's glaciers have lost roughly 5% of their total ice mass since the year 2000. While that number may sound small, the amount of water involved is enormous and is already contributing to rising sea levels around the globe. Several factors are accelerating glacier loss. Warmer air and ocean temperatures increase melting. More precipitation is falling as rain instead of snow in many mountain regions. Reduced snowpack means less fresh ice can accumulate, while darker rock and soil exposed by melting ice absorb more sunlight and generate even more warming. The consequences extend far beyond the mountains. As glaciers shrink, sea levels continue to rise, increasing the risk of coastal flooding. Millions of people depend on glacier-fed rivers for drinking water, agriculture, and hydropower. In many regions, glacier retreat threatens long-term water security. Melting glaciers can also increase natural hazards. Unstable slopes, landslides, and dangerous glacial lake outburst floods become more likely as ice disappears and mountain landscapes change. Scientists are closely monitoring these changes using satellites, field measurements, weather stations, drones, and computer models. These tools help researchers track glacier health and better understand future risks. The evidence is clear. Glaciers are retreating on nearly every continent. What was once considered a slow geological process is now occurring within a human lifetime. Glaciers are more than frozen landscapes. They provide fresh water, support ecosystems, influence sea level, and serve as one of the clearest indicators of a warming world. As temperatures continue to rise, the future of many glaciers remains uncertain. Protecting them ultimately means addressing the warming that is causing them to disappear. The ice is melting, and the changes are already being felt around the world. Sea level rise is one of the clearest and most measurable signs of a warming planet. While it may seem like a slow-moving problem, its impacts are already being felt by millions of people around the world. Since 1900, global sea levels have risen by about 8 inches, or 20 centimeters. That increase may not sound dramatic, but even small rises in sea level can greatly increase the risk of coastal flooding, erosion, and storm damage. Sea level rise occurs for two main reasons. First, ocean water expands as it warms, a process known as thermal expansion. Second, glaciers and massive ice sheets in Greenland and Antarctica are melting, adding more water to the oceans. Together, these processes are causing sea levels to rise faster today than they did during much of the 20th century. Scientists project that by 2050, sea levels along many U.S. coastlines could rise by around 1 foot. By the end of this century, the increase could reach between roughly 2 and 4 feet in higher emissions scenarios. The consequences are far-reaching. Higher sea levels mean more frequent coastal flooding, even during ordinary high tides. Storm surges from hurricanes can travel farther inland and cause greater damage. Saltwater can move into freshwater aquifers, threatening drinking water supplies and agriculture. Wetlands, mangroves, and coastal ecosystems face increasing pressure as rising oceans reshape shorelines. Some of the world's most vulnerable areas include low-lying coastal regions, river deltas, and small island nations. Many communities already face difficult decisions about how to adapt to rising water levels in the decades ahead. Scientists monitor sea level rise using satellites, tide gauges, research ships, ocean buoys, and advanced computer models. These tools provide a clear picture of how rapidly our oceans are changing and help improve future projections. The good news is that the future is not set in stone. The amount of sea level rise we experience later this century will depend largely on greenhouse gas emissions and how quickly the world acts to limit warming. Sea level rise is not just a problem for future generations. It is happening now, affecting coastlines, ecosystems, infrastructure, and communities around the world. The ocean is rising, and the choices we make today will help determine how much higher it rises tomorrow. Coral reefs are often called the rainforests of the ocean. Although they cover less than 1% of the seafloor, they support roughly a quarter of all marine species and provide food, jobs, tourism, and coastal protection for hundreds of millions of people. Today, these vital ecosystems are facing one of the greatest threats in their history, mass coral bleaching. Corals live in partnership with tiny algae that provide them with both color and energy. When ocean temperatures become too warm for too long, corals become stressed and expel these algae. Without them, corals turn white, a process known as bleaching. Bleached corals are not immediately dead, but they become weaker, more vulnerable to disease, and far more likely to die if stressful conditions continue. Over the past decade, the world has experienced 2 major global coral bleaching events. The third global bleaching event, which lasted from 2014 through 2017, was the longest and most severe ever recorded at the time. More than two-thirds of the world's reef areas experienced significant bleaching. Iconic ecosystems such as Australia's Great Barrier Reef suffered major losses, with some regions losing up to half of their shallow water corals. But the situation became even worse. Beginning in 2023, the world entered a fourth global bleaching event. Fueled by record-breaking ocean temperatures and widespread marine heatwaves, bleaching spread across nearly every major ocean basin. From the Florida Keys and Caribbean to the Pacific Islands, Red Sea, and Great Barrier Reef, reefs experienced unprecedented levels of heat stress. Scientists describe this event as the most extensive global bleaching event ever observed. In many locations, reefs were repeatedly exposed to extreme heat, leaving little time for recovery. The impacts extend far beyond the corals themselves. As reefs decline, fish populations can be affected, coastal communities lose natural storm protection, tourism suffers, and entire marine ecosystems become less resilient. The primary driver behind these bleaching events is rising ocean temperature. As greenhouse gases continue warming the planet, the oceans absorb most of that excess heat, creating longer and more intense marine heat waves. Scientists continue monitoring reefs around the world, but the warning signs are becoming increasingly difficult to ignore. Coral reefs have survived for millions of years, yet many now face unprecedented stress within a single human lifetime. The future of these ecosystems will depend largely on how much warming occurs in the decades ahead. Coral reefs are in crisis, and what happens next may determine the future of some of the most diverse ecosystems on Earth. Most people have heard of global warming, but fewer have heard of the North Atlantic cold blob. Despite a warming planet, a region of unusually cold water has persisted in the North Atlantic Ocean south of Greenland and east of Canada. This area, known as the cold blob, can be several degrees colder than normal and has become one of the most unusual ocean temperature patterns on Earth. So how does it form? Cold Arctic air, sea ice, and freshwater from melting ice sheets can cool the ocean surface. Because freshwater is lighter than saltwater, it can reduce the mixing of ocean layers, allowing cold water to remain trapped near the surface for months or even years. One of the strongest cold blob events occurred between 2015 and 2018. During that period, sea surface temperatures in the region were as much as 4 to 5 degrees Celsius below average. Scientists are paying close attention because this region is connected to the Atlantic Meridional Overturning Circulation, or AMOC. This massive ocean current system helps move heat around the Atlantic Ocean and influences weather patterns on both sides of the ocean. The cold blob may affect storm tracks, rainfall patterns, marine ecosystems, and fisheries. Some studies suggest it could even influence winters in Europe and parts of North America. However, it's important to understand that the cold blob does not mean global warming has stopped. It is a regional phenomenon within a planet that is continuing to warm overall. Researchers use satellites, ocean buoys, research ships, and climate models to better understand what is happening and what it could mean for the future. The North Atlantic cold blob is a reminder that climate change is not always simple. In a warming world, some places can still experience unusual pockets of cooling, showing just how connected and complex Earth's climate system really is. To understand today's climate, we first need to understand that Earth's climate has never been completely static. Over billions of years, our planet has experienced ice ages, warm periods, volcanic eruptions, shifting continents, and changing ocean currents. One of the most important natural climate drivers is known as the Milankovitch Cycles. These are slow changes in Earth's orbit, tilt, and wobble that affect how much sunlight reaches different parts of the planet. The first cycle, called eccentricity, changes the shape of Earth's orbit over roughly 100,000 years. The second, obliquity, changes Earth's tilt over about 41,000 years, influencing the strength of the seasons. The third, precession, is a slow wobble of Earth's axis that occurs over approximately 26,000 years. Together, these cycles have helped drive the advance and retreat of ice ages throughout Earth's history. Over geological time, Earth has experienced many major climate periods. Some were dominated by vast ice sheets, while others were significantly warmer than today. The Cryogenian Ice Age may have transformed Earth into a near snowball Earth, with ice reaching close to the equator. The current Quaternary Ice Age began about 2.6 million years ago and continues today, although we are currently living in a warmer interglacial period that started roughly 11,700 years ago. Earth has also experienced dramatic warming events. One example is the Paleocene-Eocene thermal maximum around 56 million years ago, when global temperatures rose rapidly due to large releases of carbon into the atmosphere. Volcanic activity, continental drift, ocean circulation, and natural greenhouse gas changes have all played important roles in shaping Earth's climate over millions of years. Studying these ancient climate changes helps scientists understand how Earth's climate system works and provides valuable clues about possible future changes. The big picture is that Earth's climate has always changed. Natural forces have shaped our planet for billions of years, and understanding those forces helps us better understand both the past and the future. Climate models around the world are increasingly pointing toward the possibility of a strong El Niño developing now and peaking in December 2026, then impacts lasting early 2027. El Niño is a natural climate pattern that occurs when trade winds weaken across the tropical Pacific Ocean. As these winds weaken, warm water spreads eastward, causing sea surface temperatures to rise across a large portion of the equatorial Pacific. A typical El Niño can influence weather around the globe. A super El Niño is an especially powerful version of this event, capable of producing major climate disruptions worldwide. Several factors are being watched closely by scientists. Ocean temperatures beneath the surface remain unusually warm, trade winds are expected to remain weaker than normal, and many forecast models continue to show a significant warming of the tropical Pacific. If a super El Niño develops, its impacts could be felt across multiple continents. Some regions may experience increased rainfall and flooding. Parts of the southern United States, western South America, and portions of Southeast Asia could see a greater risk of heavy rain events. Other regions may face the opposite problem. Australia, Indonesia, parts of southern Africa, and sections of Brazil could experience hotter and drier conditions, increasing drought and wildfire risks. Tropical cyclone activity may also shift. Some ocean basins could see stronger storms, while others may experience changes in storm frequency and track. Marine ecosystems could also be affected as warmer ocean waters disrupt fisheries, coral reefs, and ocean circulation patterns. However, it's important to remember that this remains a forecast. While confidence is increasing, the exact strength, timing, and impacts of El Niño will continue to evolve over the coming months. The last major super El Niño events, including 1982-83, 1997-98, and 2015-16, produced significant global weather impacts and contributed to widespread floods, droughts, heat waves, and coral bleaching events. As we move closer to winter 2026-2027, scientists around the world will continue monitoring conditions across the Pacific Ocean. If a super El Niño does develop, it could become one of the most important climate stories of the decade. Not every environmental story is a story of failure. In fact, one of the greatest success stories in modern environmental science is happening right now above our heads. The ozone layer is a thin region of Earth's atmosphere that absorbs harmful ultraviolet radiation from the sun. Without it, life on Earth would face much greater risks from skin cancer, cataracts, and ecosystem damage. In the 1970s and 1980s, scientists discovered that chemicals known as chlorofluorocarbons, or CFCs, were destroying ozone molecules in the atmosphere. This led to the development of a large seasonal ozone hole over Antarctica. The discovery alarmed scientists around the world. In response, nations came together in 1987 to sign the Montreal Protocol, an international agreement designed to phase out ozone-depleting substances. Today, the Montreal Protocol is widely considered one of the most successful environmental agreements in history. Nearly every country on Earth participated. Since the 1980s, more than 99% of major ozone-depleting substances have been phased out. The results are now becoming visible. Scientists have observed steady improvement in ozone levels around the globe. The Arctic ozone layer is expected to recover to near 1980 levels by around 2045. Most regions of the world could recover by approximately 2040, while the Antarctic ozone hole is projected to return to 1980 levels around 2066. Satellite observations show that the ozone hole is generally smaller today than it was during its peak years in the late 20th century. This recovery is important because it protects human health, ecosystems, agriculture, and marine life from harmful ultraviolet radiation. The ozone story demonstrates something important. When science identifies a problem, governments cooperate, and society takes action, environmental damage can be reduced and even reversed. The healing ozone layer reminds us that global challenges can be solved, and that collective action can make a real difference. Not every environmental story is a story of failure. In fact, one of the greatest success stories in modern environmental science is happening right now above our heads. The ozone layer is a thin region of Earth's atmosphere that absorbs harmful ultraviolet radiation from the sun. Without it, life on Earth would face much greater risks from skin cancer, cataracts, and ecosystem damage. In the 1970s and 1980s, scientists discovered that chemicals known as chlorofluorocarbons, or CFCs, were destroying ozone molecules in the atmosphere. This led to the development of a large seasonal ozone hole over Antarctica. The discovery alarmed scientists around the world. In response, nations came together in 1987 to sign the Montreal Protocol, an international agreement designed to phase out ozone-depleting substances. Today, the Montreal Protocol is widely considered one of the most successful environmental agreements in history. Nearly every country on Earth participated. Since the 1980s, more than 99% of major ozone-depleting substances have been phased out. The results are now becoming visible. Scientists have observed steady improvement in ozone levels around the globe. The Arctic ozone layer is expected to recover to near 1980 levels by around 2045. Most regions of the world could recover by approximately 2040, while the Antarctic ozone hole is projected to return to 1980 levels around 2066. Satellite observations show that the ozone hole is generally smaller today than it was during its peak years in the late 20th century. This recovery is important because it protects human health, ecosystems, agriculture, and marine life from harmful ultraviolet radiation. The ozone story demonstrates something important. When science identifies a problem, governments cooperate, and society takes action, environmental damage can be reduced and even reversed. Before we talk about today's climate, it's important to understand that Earth's climate has always changed. For billions of years, natural forces have shaped our planet long before humans existed. These natural climate cycles continue to operate today. One example is the cycle between ice ages and warmer periods. Earth has repeatedly shifted between colder and warmer climates over long periods of time. We are currently living in the Quaternary Ice Age, but in a warmer interglacial period that began about 11,700 years ago. Another important factor is the Milankovitch Cycles. These are slow changes in Earth's orbit, tilt, and wobble that affect how sunlight is distributed across the planet. These cycles operate over tens of thousands to hundreds of thousands of years and have played a major role in the timing of ice ages. Natural climate patterns also occur on much shorter timescales. El Niño and La Niña are examples of ocean-atmosphere cycles in the Pacific Ocean that can influence weather around the world for months or even a few years. Volcanoes and ocean currents also affect climate. Large volcanic eruptions can temporarily cool the planet by blocking sunlight, while ocean currents move heat around the globe and influence temperatures over long periods. The key point is that Earth's climate is influenced by many natural processes operating on different timescales. From years, to thousands of years, to millions of years. Understanding these natural climate cycles helps us better understand both Earth's past and the climate changes we see today. What is global warming? Global warming is the long-term increase in Earth's average temperature. It is measured over decades, not days or weeks. One common misunderstanding is the difference between weather and climate. Weather is what happens outside today or this week. Climate is the average pattern of weather over many years. That's why a cold day, a snowstorm, or even a harsh winter does not mean global warming has stopped. A single cold event is weather. Climate looks at the entire planet over long periods of time. Scientists track global temperatures using thousands of weather stations, ocean measurements, satellites, and climate records. When all of that information is combined, a clear trend appears. Earth's average temperature has increased by more than 1 degree Celsius since the late 1800s, and most of the warmest years ever recorded have occurred in the last decade. So why does Earth warm? The answer is the greenhouse effect. The greenhouse effect is a natural process that makes life possible. Certain gases in the atmosphere act like a blanket, helping keep some of the sun's heat from escaping back into space. Without this natural greenhouse effect, Earth would be far too cold for most life to survive. But when more heat becomes trapped, the planet warms. Earth's climate is also influenced by natural factors, including volcanoes, ocean circulation, changes in solar energy, and long-term climate cycles. These natural influences have always affected our planet. However, scientists have found that the rapid warming observed during the modern era cannot be explained by natural factors alone. The overall trend is clear: Earth is warming, and that warming is influencing weather patterns, oceans, glaciers, ecosystems, and communities around the world. Understanding how our climate system works is the first step toward understanding the changes happening today and what they may mean for the future. Today's climate is changing in many different ways, and the signs are being observed across every continent and every ocean. One of the clearest examples is extreme heat. Heat waves are becoming more frequent, lasting longer, and reaching higher temperatures. The planet has warmed about 1.2 degrees Celsius since pre-industrial times, and 2023 became the hottest year on record. A warmer atmosphere can also hold more moisture. That means when storms form, they can produce heavier rainfall. In many regions, heavy rain events are increasing, leading to more flooding, more damage, and more displacement. The oceans are changing too. Warmer ocean waters provide more energy for tropical storms. Since the 1970s, Category 4 and Category 5 hurricanes have increased by about 20%. Stronger storms can bring heavier rain, stronger winds, and greater storm surge. Wildfires are another major warning sign. Hotter temperatures, drought, and dry vegetation can make fires larger and more destructive. Studies estimate that more than half of the increase in forest fire area since the 1980s is linked to climate change. Sea level rise is also happening. Global sea level has risen about 20 to 24 centimeters, or 8 to 9 inches, since 1880. Today, sea level is rising about 3.3 millimeters per year, increasing since 1993 coastal flooding and erosion. And around the world, glaciers are shrinking. Nearly every region with glaciers is losing ice, threatening water supplies, ecosystems, and future sea level rise. The big picture is clear: these changes are connected. They affect our health, homes, food, water, economies, wildlife, and future. Climate change is not the only environmental challenge facing our planet. Pollution and litter affect the health of people, wildlife, and entire communities. While these problems may seem small compared to global climate issues, they have real impacts that can be seen every day. Let's start with air pollution. In many cities, vehicle exhaust, factory emissions, power plants, smoke, and dust release pollutants into the atmosphere. Poor air quality can make breathing more difficult, worsen asthma and lung disease, and reduce overall quality of life. Air pollution is most common in large cities, industrial regions, and areas with heavy traffic. Cleaner air means healthier people and stronger communities. Another major issue is trash and plastic pollution. Every year, millions of tons of waste enter rivers, lakes, and oceans. Some pollution comes from littering, while other waste enters the environment through improper disposal, illegal dumping, and stormwater runoff. Plastic pollution can be especially harmful to wildlife. Animals may become trapped in plastic debris or mistake it for food. Polluted waterways also damage habitats and ecosystems that countless species depend on. The good news is that everyone can help. Recycling properly, avoiding littering, participating in community cleanups, planting trees, using cleaner transportation, keeping trash out of rivers and storm drains, and protecting wildlife habitats can all make a difference. These actions may seem small, but when millions of people work together, the impact can be significant. Technology is changing the way we understand our planet. One of the fastest growing tools is artificial intelligence, or AI. AI is helping scientists process enormous amounts of information faster than ever before. From weather forecasts to wildfire detection, AI is becoming an important part of environmental research and decision-making. One major benefit is improving climate predictions. AI can analyze vast amounts of weather and climate data to identify patterns that humans might miss. This helps scientists improve forecasts of hurricanes, floods, droughts, heat waves, and other extreme weather events. AI is also helping monitor our planet. Scientists use AI to analyze satellite images that track wildfires, melting glaciers, shrinking sea ice, deforestation, ocean temperatures, and rising sea levels. Tasks that once took weeks can sometimes be completed in hours. In agriculture, AI can help farmers use water, fertilizer, and land more efficiently, reducing waste while increasing food production. AI is also being used to support clean energy systems by helping manage electricity demand, improving solar and wind energy forecasting, and making power grids more efficient. But AI also comes with challenges. Training large AI systems requires significant computing power. Data centers use large amounts of electricity and water to operate and cool their equipment. Because of this, scientists and technology companies are working to make AI more energy efficient and environmentally responsible. Many organizations are investing in renewable energy, more efficient computer chips, and cleaner data centers to reduce AI's environmental footprint. The relationship between AI and climate works both ways. AI can help us better understand environmental challenges and develop solutions, while climate change itself can affect the infrastructure that powers AI systems. The future will depend on how wisely we use these technologies. When used responsibly, AI has the potential to help scientists, governments, businesses, and communities make better decisions for both people and the planet. Over the last decade, the world has experienced some of the most significant weather and climate events in modern history. From record-breaking heat waves and floods to hurricanes, wildfires, droughts, and glacier loss, these events have impacted millions of people across the globe. Let's take a quick look at the biggest climate events of the last 10 years. Heat waves have become one of the most noticeable climate trends worldwide. In 2021, the Pacific Northwest heat dome pushed temperatures to nearly 50 degrees Celsius, or 121 degrees Fahrenheit, in Western Canada. Europe experienced a historic heat wave in 2022, with temperatures exceeding 40 degrees Celsius across multiple countries. Across Asia from 2023 to 2025, temperatures approached or exceeded 45 degrees Celsius in many regions, breaking numerous local and national records. Extreme rainfall events have caused devastating floods around the world. In 2021, severe flooding struck Germany, Belgium, and neighboring countries, causing more than 220 deaths. Texas experienced catastrophic flooding in 2025 after torrential rainfall overwhelmed rivers and communities. China's Pearl River region also saw major flooding in 2024, affecting millions of people and causing widespread damage. Some of the costliest storms in history occurred during the last decade. Hurricane Maria devastated Puerto Rico in 2017. Hurricane Ian caused about $115 billion in damage in Florida during 2022. In 2024, Hurricane Helene produced historic flooding from Florida to the Appalachian Mountains and caused approximately $78.7 billion in damage. Australia's Black Summer bushfires burned about 46 million acres between 2019 and 2020. Canada's 2023 wildfire season became the largest in its recorded history, burning more than 40 million acres and spreading smoke across North America. Meanwhile, severe drought affected Australia, Brazil's Amazon basin, and the western United States, leading to water shortages, ecosystem stress, and increased wildfire risk. Glaciers continue shrinking around the world. The Swiss Alps experienced record glacier loss between 2022 and 2023. Greenland's ice sheet has seen multiple record melt years, contributing to rising sea levels. Alaska's glaciers are also retreating rapidly, affecting ecosystems and water supplies. These events show how interconnected our planet is. Extreme heat, floods, hurricanes, wildfires, droughts, and glacier loss are affecting communities around the world. Understanding these events helps us prepare for the future and make informed decisions about the challenges ahead. We've covered a lot in this documentary. We've explored Earth's natural climate cycles, from ice ages to El Niño events. We've looked at how the climate has changed throughout Earth's history, including warm periods, cold periods, and major natural shifts that occurred long before modern civilization. We've examined today's climate trends and some of the most significant events of the last decade, from heat waves and floods to hurricanes, wildfires, droughts, glacier loss, and rising sea levels. We've also explored pollution, litter, and how human activities affect the environment around us. And finally, we've seen how technology, including artificial intelligence, can help scientists better understand our planet and prepare for future challenges. What we learn from all of this is that our world is connected. A drought can affect food supplies. A wildfire can impact air quality hundreds or even thousands of miles away. A hurricane can reshape entire communities. And melting glaciers can influence coastlines around the world. The choices we make today can affect people far beyond our own neighborhoods. But there is also reason for hope. Throughout history, people have solved difficult problems through science, innovation, cooperation, and determination. The recovery of the ozone layer is one example that shows positive environmental change is possible when nations work together. Communities around the world are already developing cleaner energy, improving resilience to disasters, restoring ecosystems, and finding new ways to protect both people and nature. No single person can solve every challenge. But every action matters. Learning about these issues matters. Helping your community matters. Protecting nature matters. And making informed decisions about the future matters. The story of our planet is still being written. The next chapter depends on the choices made by governments, businesses, communities, families, and individuals around the world. Our planet. Our future. Our choice. Thank you for watching. The future is in our hands. Let's build it together.